Good day everyone. In today's competitive automotive service industry, workshops are under constant pressure to deliver faster service while maintaining quality and ensuring worker safety. One of the most common service provided is tire fitting and replacement. Although it is a routine task, it is still largely performed using manual and structured methods, especially in small-scale workshops. In many cases, tire changing processes are not measured, not standardized, and not ergonomically designed. This leads to long and unpredictable service times, inconsistent work quality, and increased physical strain on technicians. Therefore, this project focused on applying industrial engineering techniques to analyze and improve the tire changing process at the selected service center. By treating the service bay as a manual assembly line, this study used time and motion study, process analysis, and work design principles to identify inefficiencies, establish a standard time, and propose systematic improvement aimed at increasing productivity, safety, and service reliability.
Alright, Assalamualaikum, and my name is Mohd bin Saniji. The main goal of our project is to improve the tire changing process using industrial engineering technique. Especially, we have 4 objectives. First, we aim to map and measure the current tire changing process, documenting every step and the time that it takes to complete each task. Second is we want to identify the waste and the risks, such as delay, unnecessary movement, or action that may cause physical strain to the technician. Third, we plan to define a standard time for changing a tire, which will have the accurate scheduling, labor cost estimation, and performing tracking. And our final objective is we will find the recommendation practical improvement, such as better tool placement, the use of power tool, and standardized work procedure, all designed to reduce cycle time, minimize fatigue, and ensure consistent service quality. To achieve this objective, we have conducted our study in a small service workshop that is located in Parit Raja, which is serving private car. The workshop offers service which is including replacement tire, balancing, and basic inspection, and many more. But it operates 8 hours a day, and it is particularly busy on weekdays. Most of the work is manually using hydraulic jack, tire changing machine, and hand tools. Technicians are required to stand for a long time period and handle heavy tires, which make the work physically demanding and tired for the technician. By combining our objective with this real-world setting, the project aims to show how industrial engineering method can be applied in a small workshop to improve efficiency, enhance safety, and deliver consistent with high-quality service. Thank you.
Now I'm going to present the literature review. Previous studies show that industrial engineering techniques, although originally developed for manufacturing, are highly applicable to service operations that involve repetitive and manual tasks. Researchers have highlighted that service activities with structured work sequence can be analyzed using tools such as time study and work measurement. Time and motion study has been widely used to measure cycle times, identify inefficiency, and establish standard time for repetitive operations. Studies also indicated that the absence of standard time data leads to high variability in service duration, poor scheduling, and inefficiency resource utilization. Overall, the literature supports the use of industrial engineering method as an effective approach to improve efficiency, consistency, and safety in manual service operation, which provides strong justification for this case study.
This process follows a structured methodology to ensure accurate and practical results. First, the work element selection focused on the tire changing process in an automobile workshop. The task was chosen because it is repetitive, time sensitive, and commonly performed, making it suitable for time and study analysis. Next, data collection was carried out through on-site observation during normal working hours. The process was divided into clear work elements, and several cycles were recorded to obtain accurate and reliable data without interrupting the workers. Then, time analysis was performed. The average opting time for each element was calculated, followed by the application of performance rating to obtain the normal time. Allowance were then added to account for fatigue and unavoidable delays, resulting in standard time. Finally, job design development was prepared based on the standard time results, focusing on the efficient task sequence, reduce unnecessary motion, improve tool accessibility, and better economics and safety. Overall, the methodology leads to a standardized and more efficient tire changing process.
So I will explain about our result. So our result is based on chapter 3 work study. So we use the direct time study. So this is our result based on the tire service workshop changing one tire. So we have a seat element. You can see at this slide the element that we use in this direct time study. This chapter we want to calculate average time, normal time, standard time, and the overall standard time. So for this chapter we use the formula that we learned at chapter 3, average time formula, normal time formula, standard time formula. So based on the calculation that we done, the result for calculation as shown at the table. So for the minutes of the tire, we found that the tire is 10.78 minutes per tire. So in this project we have done calculate the labor cost needed. So based on the interview that we have done, the owner said that the workers' wage is ringgit 2,100 per month, and they operating 20 days per month and 8 hours per day. So based on the information, we have calculate the labor cost per tire. So based on the calculation, the labor cost per tire is RM2.36. So mean that the cost to change the one tire is RM2.36. So we have then calculate the hour wage for the workers. So the hour workers wage workers is RM30.30. Overall, the use of a direct time study has proven to be effective in detecting the efficiencies in current working practice. So the proposed improvement solution, which include better tool arrangement, the use of power tools, and the introduction of a standard operating procedure. The project is to minimize the cycle time and increase productivity and reduce worker fatigue. As a result, the outcome of the study show that work study methodology can be successful used to small scale service workshop to improve operational performance.
So in conclusion, this study demonstrates that industrial engineering techniques can be effectively applied to improve tire changing operation in small-scale automotive workshop through direct time and motion study. The existing process was analyzed and a standard time of 10.78 minutes per tire was established. The results revealed that manual wheel nut tightening, poor workstation layout, and lack of standardized procedure were the main contributors to inefficiency and worker fatigue. Based on these findings, several improvement solutions were proposed. First, improving the workstation layout by positioning tools closer to the work area can significantly reduce unnecessary movement. Second, the use of power tools can decrease cycle time and reduce physical strain on workers. Third, developing and implementing a standard operating procedure ensure consistency, safety, and service quality. Overall, this study shows that even simpler and low-cost industrial engineering interventions can lead to meaningful improvement in productivity, safety, and operational performance in automotive service workshop. Thank you.